Hello everyone, welcome back to our channel. Today we will start exercise 2.2. But before starting, just know what is the relationship between zeros and the coefficients of a polynomial. Let a quadratic polynomial ax squared plus bx plus c, where a is a coefficient of x squared and b is a coefficient of x and c is a constant. This is a quadratic polynomial, so it will have two zeros. Let alpha and beta be its two zeros. So sum of the zeros is equals to minus b upon a, and product of the zeros is equals to c upon a. This is a relationship between zeros and the coefficients of a polynomial. Just remember this because we are going to use it in the questions. Exercise 2.2. First question, find the zeros of the following polynomials and verify the relationship between zeros and the coefficients. First part is x squared minus 2x minus 8. To find the zeros, we need to find the value of x for which whole polynomial is equals to 0. Now do this by using the splitting the middle term method that you already learned in the class 9th. In this method, you have to find the two numbers in such a way that after subtracting these two numbers you will get minus 2, that is the middle term, and after multiplying these two numbers you will get product of the first and the last term, that is minus 8. So 4 and 2 are the two numbers. After subtracting these two numbers you will get minus 2, and after product of these two numbers you will get minus 8. So now x square minus 4x plus 2x minus 8. Taking common, x is common from the first two terms and 2 is common from the last two terms. Again, x minus 4 is common from the first and the second given terms. So taking x minus 4 common, x plus 2 remain as it is. This whole product is equals to 0. So putting x minus 4 is equals to 0, x plus 2 is equals to 0. This implies x is equals to 4, x plus 2 is equals to 0 implies x is equals to minus 2. So our two zeros are 4 and minus 2. Let alpha is equals to 4, beta is equals to minus 2. These are the two values of zeros. Now for verification, verifying the relationship between zeros and the coefficients, we have to do addition. Sum of the zeros is equals to 2 and product of the zeros is equals to minus 8. Sum of the zeros already is equals to minus b upon a, and product of the zeros already is equals to c upon a. So hence proved. Second part, 4s square minus 4s plus 1. By splitting the middle term method, we need two numbers in such a way that after the addition of two numbers we will get minus 4, and after multiplying these two numbers we will get product of the first and the last term, that is 4. So minus 2 and minus 2 are the two numbers. After adding we will get minus 2, minus 4, that is the middle term, and after multiplying these two numbers we will get 4, that is the product of the first and the last term. So in the next step we have to take common. Since 2s is common from the first two terms, that is 4s square and 2s, take the factors and take common. 2s is common from the first two terms. Taking 2s common and 2s minus 1 remain as it is. From the last two terms, taking minus 1 common. Whenever we take minus 1 common, the sign in the brackets will change automatically. If there is minus, it will become plus 2s. If there is plus 1, it will become minus 1 inside the brackets. So again 2s minus 1 is common from the first and the second term. Taking 2s minus 1 common, it will become 2s minus 1, and these 2s here and this minus 1 here, bracket close. Now taking 2s minus 1 and this 2s minus 1 is equals to 0. So s is equals to 1 upon 2. Here alpha is equals to beta is equals to 1 upon 2. That is the two zeros are equal to each other and the value is equals to 1 upon 2. Now for verification, sum of the zeros is equals to 1. Product of the zeros is equals to 1 by 4. Minus b upon a is equals to 1. C upon a is equals to 1 by 4. That is minus b upon a minus remain as it is. What is the value of b? Value of b is minus 4. Minus 4 here. And a, what is the value of a? Value of a is 4. So a. After solving, we will have 1. Similarly, in case of C upon A. So what we will have? We will have sum of the zeros is equals to minus B upon A, and product of the zeros is equals to C upon A. This is what we need to verify. Third part, 6x square minus 3 minus 7x. You can write it in the general form of quadratic equation, that is 6x square minus 7x minus 3. Put it is equals to 0 to find the value of x. Now by splitting the middle term method, split the minus 7 in the two numbers in such a way that after subtracting that two numbers you will get minus 7, and after multiplying that two numbers you will get product of the first and the last term, that is 18. So 2 and 9 are the two numbers. After subtracting you will get minus 7, and after multiplying you will get 18. 6x square minus 9x plus 2x minus 3 is equals to 0 is the next step. Then after taking common from the first two and the last two terms you will get this. 3x is common from the 6x square and 9x. 3x is common. Taking 3x outside, 2x minus 3 remain as it is. Now from the first and the last term 2x minus 3 is common. Taking 2x minus 3 common, then 3x plus 1 remain as it is. 3x plus 1 remain as it is. So 2x minus 3 is equals to 0 gives x is equals to 3 by 2, and 3x plus 1 is equals to 0 gives x is equals to 1 by 3. Now sum of the zeros. Sum of the zeros is equals to 3 upon 2 plus minus 1 upon 3. After solving you will get 7 upon 6. Now this is equals to minus b upon a. Product of the zeros is equals to minus 1 upon 2, that is c upon a. Fourth part, 4u square plus 8u. Taking 4u common from the first two terms and put it's equals to 0. 4u is equals to 0 implies u is equals to 0. U plus 2 is equals to 0 implies u is equals to minus 2. These two are the zeros of the polynomial 4u square plus 8u. Next, sum of the zeros is equals to minus 2, and product of the zeros is equals to 0 into minus 2, 0. And sum of the zeros is equals to minus b upon a. Product of the zeros is equals to c upon a. Fifth part, t square minus 15. Since we know that root a whole square is equals to a, so we can write 15 as root 15 whole square. Now a square minus b square. A square minus b square is equals to a minus b into a plus b. So t square minus root 15 whole square is equals to t minus root 15, t plus root 15. So to find the zeros we need to put it is equals to 0. Then t minus root 15 is equals to 0 implies t is equals to root 15. T plus root 15 is equals to 0 implies t is equals to minus root 15. Therefore, the zeros are root 15 and minus root 15. Sum of the zeros is equals to root 15 plus minus root 15. Plus minus minus. So, root 15 minus root 15 is equals to 0. Product of the zeros is equals to minus 15. Sum of the zeros is equals to minus b upon a, and product of the zeros is equals to c upon a. Sixth part, 3x square minus x minus 4. In this part also we should have to split the middle term in such a way that after subtracting we will get a number minus 1, and after multiplying we will get 12. That is the product of the first and the last term. 3 into 4 is equals to 12. So minus 4 and plus 3 are the two numbers. After subtracting these two numbers we will get minus 1, and after the product of these two numbers we will get 12. So then taking common from the first two and the last two terms we will get this term. Then again taking common 3x minus 4 we will have this. Then equating the each factor is equals to 0, we will get the value of x, that is the given zeros. Sum of the zeros is equals to 4 upon 3 plus minus 1. After solving we will get 1 upon 3, and 1 upon 3 is also is equals to minus b upon a. Hence sum of the zeros is equals to minus b upon a. Product of the zeros. Product of the zeros is equals to minus 4 upon 3. Also minus 4 upon 3 is equals to c upon a. Hence product of the zeros is equals to c upon a. Second question. Find a quadratic polynomial each with the given numbers as sum and product of the zeros respectively. First part, 1 by 4 minus 1. Sum of the zeros is equals to 1 by 4 and product of the zeros is equals to minus 1. Since we know that sum of the zeros is equals to minus b upon a and product of the zeros is equals to c upon a. To solve these kind of questions, we need to make a denominator same firstly. Here in the denominator there is 4 and here in the denominator there is 1. So to make a 4 there, multiply both sides by, that is by numerator and denominator by 4. Multiply numerator and denominator by 4, we will get c upon a is equals to minus 4 upon 4. So now from these two equations we will get a is equals to 4. A is equals to 4. Minus b is equals to 1. Minus b is equals to 1 implies that b is equals to minus 1. C is equals to minus 4. Put c is equals to minus 4. Since we know that general equation, that is general quadratic polynomial is ax square plus bx plus c. So put a, b, c, value of the a, b, c, we will get that 4x square minus x minus 4. This is our quadratic polynomial. Second part is sum of the zeros is equals to root 2 and product of the zeros is equals to 1 upon 3. Since we know that sum of the zeros is equals to minus b upon a and product of the zeros is equals to c upon a. Here also the denominator is not same. So to make the denominator same, multiply both these sides by 3. That is root 2 upon 1 multiplied by 3. 3 root 2 upon 3 is equals to minus b upon a. So from here we will get a is equals to 3. A is equals to 3 and minus b is equals to 3 root 2, that is b is equals to minus 3 root 2 and c is equals to 1. So our quadratic polynomial is ax square plus bx plus c. Put the value of a, b, c, we will get 3x square minus 3 root 2x plus 1. Third part, sum of the zeros is equals to 0 and product of the zeros is equals to root 5. Sum of the zeros is equals to minus b upon a and product is equals to c upon a. Here denominator is same. So we will get a is equals to 1. Minus b is equals to 0 implies that b is equals to 0. C is equals to root 5. So equation becomes a x square plus bx plus c, that is x square plus root 5. This is our quadratic polynomial. Now question number 4th. Question number 4th, sum of the zeros is equals to 1 and product of the zeros is equals to 1. Sum of the zeros is equals to minus b upon a. Product of the zeros is equals to c upon a. In this case, a is equals to 1, b is equals to minus 1, c is equals to 1. So our equation becomes ax square plus bx plus c, that is x square minus x plus 1. Fifth part, sum of the zeros is equals to minus 1 by 4 is equals to minus b upon a and product of the zeros is equals to 1 by 4 is equals to c upon a. Here a is equals to 4, b minus b is equals to minus 1 implies that b is equals to 1, c is equals to 1. So equation ax square plus bx plus c implies that 4x square plus 1x plus 1. This is our required quadratic polynomial. Now sixth part. In the sixth part, sum of the zeros is equals to 4 and product of the zeros is equals to 1. Minus b upon a. Product of the zeros is equals to c upon a. From here we will have a is equals to 1, b is equals to minus 4, c is equals to 1. So equation becomes 1x square minus 4x plus 1.